Okay, so I just will leave room for Katy Silverio that is going to show her personal project and how she refactored it. Thank you.
Ciao, buon pomeriggio. Grazie tutti di voi per venire. That is all the Italian I will speak today. So I know the title of my talk is strange. A huge green snake bars the way is actually a line from Colossal Cave Adventure. And it's also a snake, so Python. This is me on GitHub and Twitter and basically everything. I used to study astrophysics before programming, so I am Astro Silverio on everything if you want to find me after the conference. I'm a developer at Venmo, which is a company in New York City. And today I'm going to talk about my personal project, which is a framework for writing and running text adventures, and what I've been doing with it for the past 3 years. So in case you're not familiar, Text Adventure is a game that has text-only input and text-only output. There's a slew of classic ones from the 70s and 80s, like Colossal Cave Adventure and Zork. There's a Hitchhiker's Guide text adventure that's really good. So in the summer of 2013, I wrote my own Harry Potter-themed text adventure game. And I intend this talk to be essentially a retrospective of how I've been changing it and improving it ever since. So the details are going to be game-specific and specifically text adventure game-specific, but I hopefully have some useful thoughts about redesigning code in general. So we're going to start by defining what a text adventure is and how it works, and then I'm going to go through some weak points in my own code, and perhaps more importantly, how I found them. And then I'll go through my solutions to those problems and finally use some metrics to see if the refactoring helped. Okay, so to answer the question of how a text adventure works, let's just try playing one. So this is a scene from my text adventure game, and there are some things that you can gather about how text adventures work just from the screenshot. So first of all, as I said before, text only in, text only out. The game is making decisions based on my input. The game has state. So at this point in the game, the player is in a room. The room contains a cat. The cat has a mood, and that mood is unhappy or discontented. And those states can change. So the player may not always be in this room. The cat may not always be discontented. But at least in this scene, you can see that there are some rules for how those states can change. So if I try and pick up the cat, which would change the cat's state from being in the room to being in my possession, I can't do that. But I can, however, change the state of another object, the cloak, from being in the room to being in my inventory. If you've ever played a choose-your-own-adventure game, you may already be familiar with this kind of state machine format and setup. And the main difference is that in a choose-your-own-adventure, you're presented with a discrete, finite set of state changes that you can make. And in a text adventure, you can try typing whatever you want and seeing what happens. Okay, so let's take what I just said and turn that into some kind of flow architecture diagram. So when a player types some input, the game has to figure out what the player actually wants to do. And then it has to figure out if what the player wants to do is allowed at that point in the game. If it is, it has to make that change, and then it has to report back to the player on what it did. So my Harry Potter text adventure uses that basic model, and it mostly works. So what's wrong with it? Well, I'm going to pick out a few architecture problems in my original game code. There will be code snippets. I encourage you to not read them too closely. I'll point out what you need to see. And don't judge me too harshly, please. This was like my first large-scale project. It's so much better now. So first of all, perhaps slightly obviously, the way I wrote my text adventure game meant that I can only write one text adventure game. And to me, that's a design problem because it doesn't necessarily have to be the case, right? Like the code that handles what happens when a player types something doesn't have to be inextricably intertwined with the code that decides that, I don't know, Expelliarmus means trying to disarm another wizard, right? Like that's not inherently connected. Okay, so that's problem one. Problem two is actually a bug that I caught when I was manually testing the game. So if you're unfamiliar with Harry Potter lore, in the Harry Potter universe, there's a sword called the Sword of Gryffindor. It's associated with the Gryffindor house in the Wizarding School Hogwarts, and there are several instances in the books where the sword will fall out of an object called the Sorting Hat if a member of Gryffindor house is holding the hat. Great. So most text adventures have a command called examine. And examine usually just returns a detailed description of the thing that you're examining. So if you examine the sorting hat, for example, you'd expect some comment describing the sorting hat's appearance. And the behavior that I want in my Harry Potter game is I want the hat to drop the Sword of Gryffindor if it's examined by a member of Gryffindor house. So I added some logic to the examine command, and that logic checks if the thing that you're examining is the sorting hat, and if you're in Gryffindor. And if those checks are true, then I change the output of examine to include some line about a sword falling out of the hat, and I, as a side effect, add the sword to the player's inventory. So, as you can imagine, this edge case, like it's really an edge case. This only happens in very particular circumstances. It will only ever happen in a Harry Potter game. But it's resulting in a lot of complexity being added to what would otherwise be a very simple function. And to cap it all off, it doesn't actually work. So this is the actual behavior before I fixed it. Imagine that your house happens to be Gryffindor, and you happen to have the sorting hat. So you release the sword from the hat. And then you examine the hat again. Well, you'll just keep on getting swords of Gryffindor forever and ever and ever. Exactly. Whoops. This is a problem. So code alert. This was my original code for the examine function. The important thing to notice here is that it's already really messy, and it's already kind of complicated. And everything except the first line of the function is for the sake of the edge case. And given my original code for the examine function, the way to fix the multiplying sword bug is to add some more logic to check if the sword already exists in the game, and only drop the sword if the sword wasn't already in the game. Again, details of the code aren't important. The relevant thing is that I'm adding yet another conditional check in here when there are already so many. So it's a bad solution, but it's indicative of an underlying bad problem. And there's a quantifiable smell associated with this problem, and that's indentation. So if I just count the tabs in the examine function, there are 18 tabs here. And all of them are for handling an edge case. And so I wrote this code in the summer of 2013. I looked back at it to make this talk, and it took me, I don't know, like an hour to understand code that I wrote. And that's a problem. So complex logic, especially for handling edge cases, just makes for unmaintainable code. Counting tabs has been a really useful trick in my refactoring of this project to help me find complex business logic hiding where it shouldn't be. And this is not the only example of code that needs to be refactored that I found by just squinting at my modules and watching for when they get super indented. Okay, so the third problem that I noticed in my original game code is how I was managing state. So I chose to divide objects into 3 classes. So I chose to define every game object as either a room or a thing or a player. And so rooms will have a description like, you are in the Great Hall of Hogwarts. They can contain things or other players. In other words, they can have an inventory. They'll connect to other rooms. They may or may not have a password, et cetera, et cetera. Like all these, for every category, there are many, many properties that each of these state classes can have. And the entire state of the game is represented by the collective state of all the rooms and things and players in the game. So this approach has a couple things wrong with it, and one of them is that, especially in my text adventure game, and I think in any text adventure game that like is of a reasonable size, there's going to be a wide variation of behavior among these three core types. So some of my rooms are password protected and others of them aren't. Some of my things, like the cat is a thing and the cat is alive, but then like the sorting hat is a thing and the sorting hat is not alive. Some things can contain other things can't. Every class has a huge variation in their abilities and behaviors. And so because I was dividing my game objects up like this and modeling their behaviors on them, all my stateful classes were very bloated and very complex. And so I relieved some of that bloat in the original game by using inheritance to share common behaviors across some of the core types. So both rooms and players will always have an inventory. So I had them inherit from a parent class that handled the inventory behavior. And so, all right, that helps a bit. But for that to really be useful, you have to make a parent class for every single behavior. And there's so much variation, even in just rooms, that like trying to formulate an inheritance tree is not possible. So just as extra justification of this problem that deserves fixing, in case you're not convinced, I sorted the modules in my game by lines of code, increasing lines of code going up and increasing number of commits going up. And lines of code and number of commits are basically rough proxies for complexity and effort. And effort is kind of like inverse stability. And you'll notice that the module containing my room class is both the most complex and the most unstable. And the vertical positions are weird because they're roughly proportionate. So rooms.py has like 2.5 the number of lines of code as people.py. Like, it's huge, it's massive. And it has way more commits than anything else. So that means that my room class was unstable and complex, which is effectively saying that maintaining and extending this three-class modeling of game object scheme was like really hard. So I could keep going, but most of the other bugs and problems in my original game code are going to be alleviated by the refactoring that I'll talk about now. And they were all also identifiable in the same way. Like, there's no other diagnostic technique that I could give you by talking about more problems. So the first problem, which is that I can only write one text adventure game, solved so easily by just, instead of writing a text adventure game, writing a text adventure framework, by which I mean a system that can be used to create an arbitrary number of text adventure games. And so to do that, we should think about how a framework will work. And a game written using a framework should operate in basically the same way as a standalone game. And the difference is that to make a functioning game from a framework, you have to initialize the engine, by which I mean the code that is like processing each turn of the game. You have to initialize that with game-specific data. So the game maker or bard has to be able to write their own custom commands, which the engine has to be able to execute. So in a Harry Potter game, you'll have spells. The bard needs to be able to give the engine game-specific words to recognize. Like in a Hitchhiker's Guide game, the phrase "don't panic" might mean something to the game. And the in-game objects have to be programmable with arbitrary abilities and behaviors, meaning in, say, a Doctor Who game, you need rooms that can be bigger on the inside than on the outside, but you don't want that in any other text adventure game you might write. So it turns out that abstracting out all of the game-specific data is actually also a solution to the second problem, which is that my commands have a lot of complicated edge case logic in them. And to illustrate why, I'm going to go through how I abstracted out commands in the framework. So to do that, first I had to decide what I want commands to do. So I expect them to do some sort of input validation. So if I type some garbage like go wand, then I expect the text adventure to be like, I don't know what you want me to do. If I type something reasonable like go south, then I expect it to try and take action on that. Now, if I type go south and there isn't actually a room to the south, then the go command should return an error. And if the go command can actually move you south, then it should move me south. Sorry, I know Siena isn't super popular in Florence, but. So what I said on those last two slides can basically be condensed into 4 responsibilities of commands. So commands must validate input. They should perform some logical checks based on the game state at the time. They should change the state if they can and if they're expected to. Like look would be a command, and look doesn't change your state. And finally, after they're done, they should prepare a response to be sent to the player. So in my new system, I wrote a command class that is, to make a new command, you instantiate the command class with helper functions for each of these responsibilities. So that means that at least all of the logic will be split up into helper functions. For example, if I were to write go in my new system, it would look something like this. I would demand that it take a direction and not any other kind of word. I would have it check to make sure that a path exists. If nothing goes wrong, I should have it move the player, and then finally return the description of where the player is. So this is a bit wordy. It's also a very look before you leap philosophy. Like my intention here is that if you type go wand, then the is a direction helper method will crash. And that's not usually my style. I'm much more a forgiveness before permission. But in this particular case, I want to have extremely tight control over my error messages. So like raising with specific messages lets me easily make the game respond with different errors depending on what's wrong. Okay, so on to my third solution. Let me just rephrase my third problem. So my third problem, I wandered off a bit about stateful classes and how my initial modeling of them was bad. Essentially, the problem is as follows. If I model behaviors on stateful classes, then they'll get super bloated and complex. And if I try and inherit behaviors, then I can't resolve the inheritance tree. So I need flexibility in terms of composing objects with the behaviors and traits that I want. And it turns out that this is a well-known problem in the gaming community, and that there's a design pattern that is intended to resolve it, and it's called entity component system. So in the entity component system pattern, I'll be saying ECS for the rest of the talk. Entities are things, like, say, a cat. And then components are groups of attributes that represent traits. So a cat might have an alive component. It might have a mood component. And the cat's mood is stored in the mood component, and the cat's inventory is stored in the cat's container component. One of the tenets of ECS is that the entities shouldn't store any information about their abilities. They're just an identity. They're essentially just a UUID that the components get associated with. I like to say that the entities are nouns and the components are adjectives. So using ECS gives me a lot of control over what traits my game objects have, and I don't need to deal with inheritance. So that's great. In terms of behavior, the S of ECS stands for system, and systems are supposed to be service interfaces for making changes to components. And so I use systems to model my behaviors. So I have a container component that's supposed to represent an inventory. So I wrote a container system that handles moving things, right? Because this is a game, so they're not actually moving. But it handles changing which inventory an entity is in. So all of the logic around move is hidden in this container system. So this is a great solution for me, but the catch was that there aren't many ECS libraries in Python. And I suspect that's because the design pattern it's inherently not object-oriented. Like, as a Python user, I would expect to know whether or not if a cat is alive by looking for an alive attribute on the cat, right? Like, I expect the cat object to hold all the information about the cat. And in ECS, it doesn't. So, shameless plug. I really wanted to use ECS, so I wrote my own ECS library for Python. And it's better than the other ECS Python systems. First of all, because I maintain it. Second of all, I understand that while ECS is not inherently object-oriented, I want to make it so, if I can. So in my ECS system, to check if the cat is alive, you actually can type cat.alive. But it really is ECS. The alive attribute is not actually stored on the cat. I just overwrote the dunder getAttr method on the entity class, so it looks in all the components first. I'm very proud of that trick. So if you're interested in this design pattern, here are some resources. The first two are just articles that I found helpful when I was learning about ECS. The third is my ECS system. I know it's a shameless plug, but I really do think my README is pretty good. And it works, and I maintain it. So if you want to play around with it, please feel free. And the fourth one is a Ruby ECS library that my friend is developing. It's not Python, but he writes beautiful code. Okay, so after all of that, that's how I think I fix my problems. Let's see if all that refactoring did anything worthwhile. So I didn't even make a slide for checking to see if making a framework obviated my first problem, because it obviously did. Let's see if I successfully dealt with the second problem. If you remember, I should probably reorder this talk the next time I give it. My second problem was that I had a lot of edge case business domain logic in my commands. So to see if making a framework and refactoring commands actually worked, let's count the tabs in my new version of examine. And so I have to admit, I didn't do this quite right. So this is examine reimplemented in the new framework. I'm saying I have to make sure that I'm examining a thing. The thing function is not right anymore. I'm saying that the rules are the player has to be a Gryffindor. There should be another rule saying that the thing has to be a sorting hat, and there should be another rule saying that the sword can't be in the game already. So I'm missing a couple of functions, but they would really only have one tab each in them. Think about it, one of them is if thing is not sorting hat raise error. Like that's a one tab function. And same with the other one. So this is a little incomplete, but it's still way less indented than it was previously. I'm down to like order 5 tabs instead of 18. So that's good. I'm not 100% done with this yet, though. So one thing that you might notice from looking at this re-implemented version of Examine is that if I just look at this and I know nothing about my game and why, the like whole history of why I wrote this way, I would assume that the default behavior of Examine is to drop the sword of Gryffindor. I would assume that Examine is always trying to drop the sword, and most of the time it won't because of these logical checks. And that's not really how I want this. This is not really how I want to treat edge cases. So I'm calling 2 like halfway there. I have some ideas. And for 3, let's see if I fixed my bloated state class problem by just implementing some custom classes. So this is how you'd compose some classes using Braga, which is my ECS system. I didn't fill out all the components because it would have taken up too much room on the slide, but that's where all the state information goes. Every component only specifies one attribute, so they're probably going to be very small. You should try to make your components very small. And then all the behavior logic is in the systems. And so there's no complex logic or attributes on the state classes themselves. And to make state classes that are almost the same, you just have to define them with like almost the same component set. So what I did here was I said, well, a room is a thing that has a description. It can contain things. It could connect to other rooms. It has a name. And if it's locked, then it also has a password-protected component. And that's it. They will behave exactly the same except for that password behavior. Okay, so I intended this talk to be mostly thoughts about refactoring personal projects, especially through the lens of my own project. So here they are, the 5 steps to good project design according to me. Accept them at your own discretion. 1, make sure that your code is tested because you'll find bugs. 2, try using even really simple metrics, just like number of tabs, number of commits. Use simple metrics like that to find complex and unstable parts of your code and target those areas first. There's actually a book called Your Code is a Crime Scene that is all about refactoring, and that's where I got most of my opinions about how to use tabs and lines of code and commits to find problem areas. I highly recommend it. Thirdly, you're a user as well as a creator, so if something is bothering you, fix it. Because if it bothers you, guaranteed it's going to bother everyone else because they don't have the same knowledge of your code as you do. Fourthly, make sure that you have well-defined layers of code. I feel weird saying this because part of me feels like this might just be a me problem, but I've actually looked at a lot of code and personal projects written by other people, and like not separating out your logic into like a data layer and then a service interface, like not doing proper separation is actually a super common problem. So I'm throwing it up there. And lastly, same as firstly, make sure that your code is tested because that will help you a lot when you start changing everything. All right, that's about all I got. If you're curious, the first link is my text adventure framework, and the second link is my ECS package. And I will take questions.
you, Kati. Are there any questions?
I also, sorry.
Oh, you can say.
I was going to say, I also have demos if there are no questions and people care.
So, would it have been feasible to make the program entirely data-driven rather than having the lowest layer sort of be a code layer?
Okay, so yeah, the question was, would it be possible to make the entire project data-driven? Yeah. I think that's what I'm aiming for. If by data-driven you mean like having the specific game data control, like.
Imagine that all the code was. Wait a second. Imagine that all the code was, agnostic about what the game was.
Oh,
and
yeah.
that everything was just, read out of like a YAML file.
Yeah. That's what I'm going for. That's totally what I'm going for.
Any other questions?
You say that you had the tests. So did the test help you to catch all the bugs during the refactoring, or?
No. So the tests that I have in place for my refactoring are entirely sanity checks. I was going to give a demo of like mini game that I wrote that has bugs and it has problems, but all the tests are passing. And it's just that if you manually test it, there will be like weird edge cases. But sanity checks are super helpful too.
Do you test the game logic itself?
So the way I'm currently, the way my tests are currently set up, I have, at least for the like mini game that I'm working on, I have a suite of tests that does not like unit test the game logic. It just gives the game strings and has it process those strings. And then I have another suite of tests that actually, for each, it goes command by command and tests the logic command by command. That's what I'm currently going with. We'll see if I stay with it.
Any other?
You mentioned that you used a couple of metrics like the number of commits and the number of lines of code to spot which modules would need refactoring most. Do you have any tools that help you with calculating those metrics?
There is a tool that exists. It's written by the guy who wrote Your Code is a Crime Scene. And it's called Code Mat. Called MAT, COD-MAAT. For this talk, I didn't use that. I just did like WC-L for all of the modules in my game. But those like tools exist.
Any other questions?
Have you ever thought about firing up a sort of neural network in order to test your game, or maybe also using your game to make some, I don't know, experiment on neural network and natural language recognition?
That's a good idea. I haven't thought of that. That's a really good idea. Yeah.
Other questions?
If you borrow my laptop, it's local only for now. So my my development strategy from here on out is make tiny mini games, because the like full Harry Potter game is going to be it'll be years. Honestly, it'll be years. But I have a mini game that's just dueling that works locally, and I'm going to make it available on the internet somewhere soon. So my general plan is just to make mini games that will let me develop small bits gradually, and then put them up.
Hi, for testing, what happens if you use something that kind of explores randomly, like depth first or breadth first or whatever other search, all the states that are possible, and tries to look for a bug and plays the game? And here I'm not thinking of like neural networks, but more of something genetic that probably can be instructed with some kind of rules that can change over time.
Yeah. So one thing, the direction that I kind of see this going in is, like even the mini games that I'm writing, I am only able to write them because I've written the code of the framework. So I want to add some developer tools so that other people can actually use it. And one of the things that I want to do is allow the framework to be able to test the game for, like, say, unreachable states, or states that once you get in them, you can't get out, stuff like that.
Okay, I think we have time for like 1 or 2 more questions. Okay, so thank you, Kati.